I'll just do one of them because they're all essentially the same idea. The idea, the approach that you want to use involves not finding the inverse. Right, so we don't want to actually find the inverse. We use a table approach. Right, so that's where a graphing calculator comes into play, or Desmos if you want. All right. It really doesn't matter which one you use, but I'll stay away from one of the simpler ones because those are usually pretty easily invertible. Right? Actually, all of these are invertible. The one you get on the ticket tomorrow won't be. Right? So it's not like you'll have a choice in the matter. Invertible just means that you can't find its inverse just by simply switching the x and the y and solving for y. Right? Not to say that one can't do it. It's just you can't do it because you haven't been taught the necessary skills to handle converting or inverting the types of problems or the type of problem that I give you tomorrow. So it'd be just think of a more complicated polynomial function. Bottom line is the approach is going to be very similar. You type in your original function into the calculator. So let me get this stuff out of here. All right, so x to the 2/3. Raise it up to the 2/3 power plus 5. All right, that's all you have to do in terms of inputting any information. Everything else is just going to be what you get out of the calculator. You should have already the derivative function in there. If not, then okay, maybe you do have to input something else. But that's math, option 8. And you'll see this monstrosity. But it's glorious because it's going to do the derivative for you. So you type in x. You need the y1. We need to reference y1 here. So we select alpha trace y1. If you do it this one time, you don't have to do it again tomorrow. You just save it. You know? So, and then x equals x. So now in my y1 column, I'll have the y values for the corresponding x values for the function. And then in y2, I'll have the derivative at those particular x values. Right? So I'm just going to go to the table now. Second graph. Got a big old table here. So I need to find the number 6 in the y1 column. All right. So now I am going to ask you to build a table on the ticket, but it's not going to be an overly lengthy one. Just something like -2 to 2, right? Just to show that you're using the approach. Right? So I'll actually do that here. So I'll build a table from -2 to 2. This kind of looks like a rectangle. So x, -2, 0, -2, 0, -2, -1, 0, 1, 2. We'd have the f of x values and the f prime of x values. All right, I already constructed the table. So on the ticket, you'll have the table already constructed with the x values already plugged in. You would just have to give me everything else. All right. I'm sure it wasn't that impressive. So 6.5874, you know. I mean, just kind of grin and bear it. You just write it in. 6, 5, 6, and then another 6.5874. Then for the derivative values, -0.5291. The next one would be -2/3, so I'm just going to write that. If it's obviously a recognizable decimal, then go ahead and just write the fraction that corresponds with that obviously recognizable decimal. You know, just save yourself the energy. All right. 0, +2/3, 0.52913. I'll move the calculator in a sec. I'll just go 4 decimal places. That's fine. All right. So now I have the table. All right. Previously, you were given the table or you were just referencing the calculator. Basically, like I said or alluded to earlier, I just need evidence that you're using this approach, right? So, and the evidence is you creating the table. So if I want the derivative of the inverse function at the n value of 6, which is what the directions for these problems are telling us to do, I would need 1 over it's really just that formula. So 1 over f prime of the inverse at 6. So 1 over the negative 2/3, which would simplify to negative 3/2, keep change flip, right, or 6 corresponded to a positive 1, which in turn corresponded to a 2/3, which would give a result of 3/2. So in this case, not always going to be the case, but in this case, plus or minus 3/2 would be your solution. Function, I need a table out of this though. So I'm going to click on this gear icon and click table. All right. Then in a new column, I'm going to type in f prime of x, and that's going to give me my derivative values also. So it'll start off giving me the table that it wants to give me. It wants to give me a table going from -2 to 2. Well, I need something that's going to get me as high as 27 in the y column. So not quite there yet. All right. But it's also not going to just give me the derivative column. I have to type that in. All right. So to expand my table, it maxes out at 3. I just highlight, it maxes out at 2. I highlight the 2, hit enter, and it auto-populates. I can go as far as I want. All right, but it turns out I only needed to go as far as 3 to get what I needed to get. All right, and so that shows that the y value of -27 corresponds with x value of 3, which in turn corresponds with a derivative value of 27. So f as an inverse is derivative. Pen not working. There we go. At 27 is equal to 1 over the derivative of the inverse at 27, which coincidentally is also 27. Doesn't always play out that way, but that's kind of interesting. So 1 over 27, and that would be it. All right. The difference between this approach and the other approach is that you're just getting your table a different way. And also it's automatically giving you the graph, which you're not even going to reference, but yeah, you just pull the numbers. You're handwriting the table, so you just pull the numbers right off of the Desmos table, just like we would on the TI. They're cleaner numbers, so it should be easier. All right.